Now that we've learned a little bit about adding and subtracting some integers, let's go ahead and throw real number operations in together. So when I say real numbers, I'm going to be talking about integers. I might be talking about fractions that have signs attached to them, so a positive and a negative fraction, as opposed to just having all positive fractions. That's the idea of real numbers. So we're going to start really basic at first here. We're going to start with order of operations. Remember, that's PEMDAS. Parentheses, exponents, multiplication, division. Remember, multiplication and division, these go in left to right order together. And addition, subtraction, and remember, addition, subtraction go in left to right order. And we're going to start by just throwing in some really simple basic integers. So as I look across this first example, I have a negative 3 plus 15 times 2 divided by 6. I have no parentheses. I have no exponents. So the first thing I see is multiplication and division. So multiplication comes before division in this case, so I'm going to do this. 15 times 2, that's 30. And then once I have that, the next thing to do is the division problem. So I have a negative 3, copying it down, plus, and then 30 divided by 6, which is 5. And now I'm back down to the basic addition problem of negative 3 plus positive 5. So I have opposite signs. I'm going to take the larger number, 5, and I have 3. I'm going to subtract from that because those two are opposite signs. And when it's all said and done, the larger sign is going to be the sign of my number. So 5 is larger, so it's going to be a positive number. So 5 minus 3 is 2, and it's positive 2, and I don't have to write that positive. So there is my answer, positive 2. Now moving on to my next one, a little bit more problem here. So I have negative 3, subtract 7, plus the opposite of 2 times 5. Remember that opposites are written as a negative sign outside of a number. Okay, so the first thing I'm going to do here is I'm going to change this subtraction to an addition. This is plus a negative 7. And that way I don't have to switch myself back and forth between addition and subtraction. Now the next thing I want to do is I want to see that parentheses, right? And inside these parentheses is just a multiplication problem. And inside that multiplication problem, I have 2 times 5, which is simply 10. And then it says I want the opposite of this 10, so that's a negative 10. So this all together says negative 10 because that is positive 10 and then the opposite of it is negative 10. And then I simply have a negative 3 plus a negative 7 plus a negative 10. Now, they're all the same sign. So it's just like when we did addition of a bunch of numbers before we learned integers. I'm just adding all of them up, right? And when I add all these up, I say, oh, that's plus a 3, or 3 plus a 7, and then plus a 10. And because they're all the same sign, when I'm done, I'm going to attach that sign, which is a negative sign. So 3 plus 7, which is 10, and then 10 plus 10, which is 20. So I've got 20, and it's a negative 20. So there we go. That's our final answer. All right, moving along, I'm going to give a problem for you to try on your own. Actually, there are 2 problems for you to try on your own here. So we have this first problem, the opposite of negative 3 plus negative 7 and divided by 2, and negative 5 plus 10 divided by 5 minus 1. So why don't you go ahead and shut the video off now, give that a chance on your very own without my assistance, and then come back and see if you've got the right answer. All right, hopefully you've given that some chance on your own. You shut the video off and did this on your own, so let's try the first one at least. So the first thing I want to do is I want to do these parentheses here. So I have a negative 3 plus a negative 7. So those are the same sign, so the rules say that I'm going to add these two numbers up, 3 plus 7. And then when it's all said and done, they'll be negative because I keep that common sign. So that is going to give me a negative 10. Now, once I have that, this out here says, oh, I want to do the opposite of that. So the opposite of a negative 10, which is going to give me a positive 10, and then positive 10 divided by 2, which is equal to 5. So my final answer is 5. Now, if you haven't done the second problem, I again encourage you to go ahead and shut the video off and do that on your very own, and then come back and take a look at the answer. So parentheses, no. Exponents, no. Multiplication, division. Well, we have a division problem here. So 10 divided by 5, which is 2. And then this one, I don't want to deal with any subtraction, so I'm going to go ahead and change that to an addition problem. Add the opposite of the number after, so plus a negative 1. So now I have negative 5 plus 2 plus negative 1. Well, now comes a property that I can use here called the commutative property. I'm going to say that this is negative 5 plus negative 1 plus a positive 2, the commutative property of addition. And these two numbers are like signs, so I'm going to be adding those two numbers together, right? So 5 plus 1, which is 6, and when it's all said and done, they're going to be negative. So I'm going to get a negative 6 out of this. And then I have negative 6 plus 2. Well, those are opposite signs. And so I'm going to take the bigger number 6, I'm going to subtract the smaller number 2, and then I'm going to keep the sign of the larger number, which is the negative sign. So when all is said and done, I'm going to have a negative 4, and that will be my final answer. All right, now we're going to move on, and we're going to up the ante here a little bit. Oops. We're going to throw in some fractions. So we're going to first of all just throw in some fractions to order of operations, and then we'll throw in integers as well as real numbers. So we have 1/2 plus 1/3 divided by 2. Order of operations says first of all the division is first. So the way I divide with fractions, remember, is multiply by a reciprocal. So this says 1/3 times 1/2. Remember that 2 goes over 1, and the reciprocal, we flip that over. So we take 1/2. And then to multiply these, we multiply straight across the numerators, 1, straight across the denominators, and that's 6. So now my new problem becomes 1/2 plus 1/6. Now, of course, I need to find the least common denominator. Now, don't just go ahead and make the common denominator 2 times 6. That's a waste of your time and effort. The LCD of this, 6, remember, was 2 times 3, right? So the LCD of this is actually 6. So this is going to get built to 6, and 1/6 is going to stay as 6. So I say to myself, what times 2 gives me 6? Well, that would be 3. So I'll multiply the numerator by that. So now I have 3/6 plus 1/6. Don't get carried away. Remember that 3/6, I don't want to reduce it back down. I purposefully made that have common factors so that I can add. Now I'm going to add the numerators, 3 plus 1, which gives me 4, and I'm going to put that over my common denominator, 6. But with addition of fractions, we're not necessarily finished. 4/6 has a greatest common factor, and so I can do this in one of two ways. I can do the prime factorization, or I can find the GCF. Well, I already have factored 6, and the factors of that are 2 and 3. So the factors of 4 and the factors of 6, the greatest common factor is 2. So I'm going to go ahead and I'm going to divide out that greatest common factor of 2, and I see 4 divided by 2, which is 2, and 6 divided by 2, which is 3, and 2 and 3 are only separated by one number, so I know that that's as low as it can possibly go, and that's my final answer. Now moving on to the next one, you see I've upped the ante here. I've put some integers into it, so I put the signs in it. They're actually called real numbers, okay? But the idea of having an integer, you think of signed numbers, so that's kind of, I refer them to that as a sign or as an integer, more as slang, because 5/8 is not an integer, so it's technically not correct to say that. All right, so what we have here is parentheses first. So here's where I'm going to start. So the first thing I have is, oh, well, there's some canceling that can go on here. So I'm going to cancel here, and that's going to give me a 1 here and a 2 here. Remember, canceling is dividing out a common factor. 2 and 4 have a common factor of 2, so 2 divided by 2 is 1, and 4 divided by 2 is 2. And now, multiplying the numerators, I get a 2, and multiplying the denominators, I get a 5. Now, I can say, oh, well, this is negative 5/8, and then plus 3/8, and then plus, and I'm going to change this to addition, right? Add, and then the opposite of this, which gives me a negative 2/5. And so now, once I have that, the next thing that I'm going to do is I'm going to go ahead and do the commutative property again. So I have negative 5/8, and I want to add a negative 2/5 to that. And then when that's finished, then I can deal with the positive one. So negative 5/8 and negative 2/5, I can't do anything with those until I have a least common denominator. Well, 5's a prime number. And so because 5 is prime and 8's made of 2's, there are no common factors. So my least common denominator is simply going to be their product, which is 40. So we're going to build the higher terms to 40ths for those two. So I'm going to have 5 times 8 and 5 times 5. And so this is going to give me a negative 25. Now, the negative, it's just going to stay out there. It says the opposite of this fraction, right? So don't worry about it. It's just going to stay there. And this one's going to be an 8, and this is going to be an 8, and 2 times 8 is 16, and that's a negative number. Now when I add two negative numbers, it doesn't matter that these are fractions. When I add two negative numbers, I'm adding the numbers and keeping their common sign. So this is going to be 25 plus 16 over the common denominator of 40. So we're still going to have a negative fraction, and it's going to be 25 plus 16. So 6 plus 5 is 11, and then I carry the 1, and 2 plus 1 plus 1, which is 4. So I have 41, which is negative 41 over 40, and then I'm going to add to that 3/8. Now, some methods go that instead of just doing these piece by piece, you find the least common denominator for all the denominators, build all the higher terms, and then just add as necessary. I don't like to do it that way personally because I find that sometimes I do more work than I need to. So I like to get all the negative numbers together, all the positive numbers together, and then kind of see whether I need to build the higher terms all across the board or whether I should just wait. Now once I get it to this point, I see, well, you know, the common denominator of 40 is a really good idea, so let's build the common denominator here to 40 as well. So now I have 3 times 5, which is 15. Now when I have a negative number and a positive number, it doesn't matter if these are fractions, that's all just going to work out in the wash. I carry that common denominator along because they are fractions, and because I'm adding two numbers that are opposite in sign, I take the bigger number, 41, and I subtract the smaller number, 15, and those are just the numerators, so that's why they're going in the numerators, and then I keep the sign of the bigger number, which is 41. And 41 minus 15, I have to do some borrowing, right? So there's a 3, and then there's a 1, so 11 minus 5 is 6, and then 3 minus 1, which is 2. And you got to remember it's a negative, and then that goes over the common denominator. And once again, because it's fraction, right, we always have to check in the end to make sure that this thing is reduced, and they're both even, so I know it's not reduced. Now I actually know that 26 is 2 times 13, so I know that there's not going to be anything more than this 2 in common, but you may need to do a little bit more rigorous methods. Now a negative number is still going to be a negative number, right? So don't forget to put that sign out of there. And 26 divided by 2, which I told you earlier, is 13, and 40 divided by 2, which is 20. And 13 is a prime number, and therefore, since how 20 doesn't have any 13s in it, we would know it would be reduced. All right. Now, this one is the one that I would say is your turn, but I'm pretty much out of time, so I'm going to let you do that one on your own, and then you can stay tuned for the next video and come back and see your answer in the next video.